Dear friends, in this video, in the power plant engineering, in the first video, the first topic, how to improve the efficiency of the power plant, thermal power plant. To improve the efficiency of the thermal power plant, we need to concentrate on the cycle, thermal cycle on which the power plant is working. The Rankine cycle is the steam power cycle which is used in all the thermal power plants. So if we increase the efficiency of this Rankine cycle, we can increase the efficiency of overall thermal power plant. So this is a very important area where we have to concentrate so that we can minimize the wastages and we can increase the power output. At the same time, we can maintain the components of boilers. So here there are three methods to improve the efficiency of the Rankine cycle. One is decreasing the condenser pressure. Second one is increasing the boiler pressure. Third, increasing the superheating steam temperature to the maximum possible level. Here we are saying that condenser and boiler, these are the important components in any thermal power plant. If you look at this diagram, that is a temperature entropy diagram, which is the basis for understanding the working of Rankine cycle. You look at this saturation curve. This is called the saturation curve. This blue color dome is called the saturation curve. This is 1 to 2, 2 to 3, 3 to 4 and 4 to 1. 1 to 2 is the constant entropy isentropic process. 3 to 4 is the constant entropy isentropic process. 4 to 1 is the constant pressure heat rejection. Similarly, 2 to 3 is the constant pressure heat addition. So our aim is to reduce the condenser pressure. This is one of the methods to improve the efficiency. See, by reducing the condenser pressure, the normal cycle shows 1, 2, 3, 4. If we are reducing the condenser pressure, here the point 1, 4, 4 dash and 1 dash. This is the area. This blue color shaded is the area. If we reduce the condenser pressure, the temperature drip diagram looks like this: 1, 4, 4 dash, 1 dash. 1, 4, 4 dash, 1 dash shows the net increase due to reduction in condenser pressure, thereby increasing the cycle efficiency. That is, it reduces the pressure, causes the reduction in temperature at which heat is rejected. This point we have to understand. The initial temperature is this one, T1 equal to T4. This is the initial temperature. Whereas by reducing the condenser pressure, the temperature at which heat is rejected is reduced to this level. So by reducing the temperature of the condensate, we can increase the output, so that we can increase the net work output, then thereby increasing the Rankine cycle efficiency. The area under the curve Ts will be increased. The heat energy will be increased automatically. It will increase the overall efficiency of the plant and the Rankine cycle efficiency. We may think that if we reduce further condenser pressure, what will happen? Yes, we should not reduce the condenser pressure below the saturation pressure. That point we have to observe here. If we reduce the condenser pressure below the saturation pressure, and the vapor also will be formed and air will be sucked into the condenser due to the high pressure surrounding the low pressure condenser. So this will not work out. So we should not reduce the condenser pressure below the saturation pressure. That point we have to observe here. This is the first method to increase the Rankine cycle efficiency. Let me repeat. This is a normal temperature. T1 equal to T4 is the normal temperature. If we reduce the condenser pressure from P4 to P4 dash, the temperature also reduces to P1 dash. That is, heat rejected and the condenser pressure is reduced. And overall area below the line in the Ts diagram will increase from 1, 2, 3, 4 to 1 dash 2, 3, 4 dash. The area is increased, so the heat is increased, so efficiency also increased. Second method is increasing the boiler pressure. In the previous method, we have reduced the condenser pressure. Now we are going to increase the boiler pressure. That means it will increase the boiling temperature of the steam. As we know that the pressure and the temperature are directly proportional. If you increase the pressure, that boiling temperature will increase. That is the basic concept we have to understand. The area here, we are showing this area that shows the net work increase. If you increase the boiler pressure, the temperature also increases from 2 to T2 dash to T3. This will increase the net work, so that we will be gaining increase in output. This is the second method. The third method, we are going to increase the superheating temperature from 3 to 3 dash. This superheated steam will get expanded in the Rankine cycle, and it will ensure the longer blade life, since moisture will not be there in the steam which is expanding the turbine. The absence of moisture will increase the turbine life. That is, erosion will be decreased. So it will save the turbine blade, as well as it will increase the net work output. So these are the three methods to improve the Rankine cycle efficiency. Everything will have some side effect. This reduction in condenser pressure, increasing the boiler temperature, and increasing the boiler superheater temperature. Reduction in boiler condenser pressure, increasing boiler pressure, increasing boiler superheated temperature. These are the three ways, but it has some side effect. If you bring the temperature below the saturation, the liquid will again become the vapor, and it will be sucked into the condenser due to high pressure surrounding and low pressure of condenser. So it will not be the good for condenser construction. And the corrosion will happen if you increase the boiler pressure, since the moisture content will be there in the vapor. So we should not increase the beyond certain limit. And third point, if you increase the high temperature, it may destroy the blades also. So we have to optimize all the three values: reduction in condenser pressure, increase in boiler pressure, increasing the superheated temperature. All the three should be optimized, so that we will get better efficiency and better life of the components of power plant. Okay, thank you for watching this video.